line segment?
6 inches. 6 inches.
How'd you do that?
That's 8 minus 2 is 6.
So you did 8 minus 2 equals 6?
I
Well,
just knew it.
you guys are using what's called the ruler postulate. From your vocab stuff, can anyone remember what a postulate is? Or a theorem? Have you guys heard theorem before? A theorem?
Heard of it.
Heard of it? Postulate? Any idea? Well, okay, so we have a postulate and a theorem. Two different things. A postulate is something, a rule that we accept as true. No proving whatsoever. So nice, we don't have to prove anything. While a theorem is a rule that can be proved. We're not worried about that, but I want you to see the difference between the two.
What the heck?
Because postulate, we're dealing with now. And you guys just use what's known as the ruler postulate. That means we have an endpoint and they're given real numbers. And we can find the distance by subtracting the two. But I want you to notice, when we're doing this, when we write the distance of a segment, we don't put the line segment above. When we write the length of a segment, we need it. So, when we talk about the distance of AB, we don't write the line segment symbol above, because we're talking about a distance. Now, I want you guys to, anywhere on your line, put a point somewhere in the middle. But I want you to try and see if you can do it like on a whole number with your ruler. And you'll see why in a second.
So I just put a random dot somewhere?
No, you
Like-
have to put it on a whole.
I'm going to
Well, I know
write
that, I'm
C.
just saying.
So yeah, you can pick any whole numbers.
So here was 2, here was 8.
We're going with 4.
Oh man, we're thinking the same today, Carson.
Wow.
Anywhere. Now, can anybody tell me something about these two segments, your two segments? So let's pick, Dylan, where did you put yours at?
3 inches.
You put it at 3 inches? So what can you tell me about your segment, the two segments that you have?
That AC is 3 inches and CB is 3 inches.
So you put it at 3 inches?
I put it in the middle.
Oh, you put it in the middle. Oh, so 3 inches away, you mean?
Yeah.
Right, okay, I took it as, so you did 5, and you did ACB. So he is saying that he's thinking, well, this one's 3 inches, and this one's 3 inches. What does that equal?
6 inches.
Is that our distance of our whole part?
Yeah.
So, another postulate that you guys just found out on your own. The segment addition. What this is saying, if we have our point, any point between this, I want you guys to write this down in your notes. The segment addition postulate is saying, if we have a point C in between 2 points of our segment, what did Dylan just tell us?
You can add them.
We can add them, right? We can add the two segments together, this one and this one, to get us our whole part. So, that's what we're going to put. If we have a point in between the two, then if we add AC plus CB, we get AB. And notice, why don't I have the line segment symbol above that? Does anyone remember what I just said?
Because distance.
Because it's a what?
Distance.
Because it's a distance. We're talking about a number. So we don't put the segment symbol above it. If I work backwards then, what is this going to be? If we know AC plus CB equals the whole thing, what's that tell us about a point? We're going to have C in the middle, right? So same thing. We're just working backwards. So we can do it either way. Notice what I have here. The points have to be collinear. I can't have point D out here and say that AD plus DB equals that, can I?
No.
They're not going to be equal. So, segment addition postulate. If we know a point in here, and we're given this in the total, well, we can find this. We can easily find that because we know the total and one length. So, I'm going to have you guys try a few. If you grabbed a marker, you can do these on your desk. If not, you can write these in your notes. So, I want you to find, here we got AB, we have BC. I want you to find the distance of AC. Find the distance of AC.
Oh. AB plus
And you honestly might be able to do this in your head.
AC 36 plus 43. No. Not even 59.
And then number 2, find LM. Find the distance of LM.
32.
It's a little different because we're given the total and we're given one chunk, but we need to find the missing one.
32.
I'm going to go write the number 1 up. You can take your markers. 2, did you get number 2?
Yeah, I'll do it.
You want 2? Yep. So you want me to write it out here? Okay, so what did that segment addition tell
Do it
us?
over this way a little bit, Kaylee, so we can get it on the camera.
We have a point. Do you have a point in the middle? Okay. And we have AB and BC. Do you have points to the two? So if we want to know how long this is, right? Isn't that what that told us? Yeah. So that's different, but we just want right here. But now LM is kind of backwards. So we added these two together. Now we have a whole chunk and part of the chunk. So how do we want to find the missing chunk? The racist thing. You got the answer for that? Number 2. Thank you. We have no whole length, right? Here we added the 2 short ones to get the big. Now we're given a big and a small. How do we find this? Yeah. So we subtract the chunk of it to get that. So number 1, where's that at? On the bottom? Yeah, it's on the bottom. Number 1, right? Segment. How come we can just add them together?
Because we know what both of the things are.
We know what they are, right?
Yeah.
And what was that, Carson? What was that postulate that tells us we can do that?
Huh?
What was the postulate we just learned that tells us we can just add those two together?
Oh. I don't know the formula.
No, not the formula, just the name. How come we can just do this?
Find the missing one. Yeah, go back.
What was that?
Segment
What's it?
addition.
Segment addition, a postulate. That's why we can add that. Now the difference with this one is what?
There's a
We're
missing
given a whole part,
Yeah.
and we need to find the missing one. But could we have found it if we weren't given this?
No.
No. It ends up being that this 32 and this was what?
32.
32. So what do you know about 32 and 32? What?
64.
That equals 6.
Equals 64. Now what can you tell me about these two segments then? They're what? They both equal 32, so they're what?
Equal.
Equal. The distances are equal. That's where we get our congruent versus equal. So, what do you think? Are lengths equal or are segments equal? One's equal, one's congruent. Think about it. Do we have equal lengths or do we have congruent lengths? Antonia?
Is it equal segments congruent lengths?
Whoops. Perfect.
Okay.
Now, do you know why?
Because
Why are
a segment is measured. I don't know.
right? Because lengths are equal because they are numbers. Numbers aren't congruent. Numbers are precisely equal. They're exact the same, right? So if you I'd write this down. This is something important to write down. Lengths are equal because they are numbers. If that helps you write because we have numbers. Lengths are equal because they represent numbers. Now, segments then are what?
Congruent.
Do you know why segments are congruent?
Because they aren't measured, they aren't a length.
There's no exact measure, it's just a figure. Like if we just had if we had two triangles, we can't say they're equal because we don't know the distance of them, we don't know exactly things. So we say figures are congruent. Lengths equal, figures congruent. Can anyone tell me how I'm going to write that then? This hash, or this tick mark, we've gotten to know means that they're what? These two segments are what? Congruent, right? We've learned that tick means they're congruent. So if I want to write out that the distance of AB and the distance of EF are equal, how am I going to finish that?
AB equals,
AB,
I can't read the first one, something F, EF.
EF. EF. Can someone tell me why I'm not writing the segment symbol over these again?
Because they're lengths.
They're lengths, they're a distance,
Yeah.
not just a figure. So, segments then. If we said they're congruent, does anyone remember the congruent symbol?
Is it like
Do you think you got it?
no?
Does anyone think they remember Fish Out in the West maybe a couple years ago if you learned congruent? Yeah, you got an idea? Has a squiggly. It has a squiggly.
Is it two lines with a squiggly?
Yep, go write it. Squiggly. You know what a squiggly is called?
About,
It's called a congruent.
Close.
It's like
Something, I would shift something a little bit.
equal sign over it.
The line sideways.
Equal sign. Yep, Anthony was helping me out. And write it under segments. Right, because lengths are equal, segments are congruent. So he's getting there, right? He's getting there. He's got one. Come on, Anthony.
Good luck.
Oh.
You're getting it. You had it all turned. You're getting there. Perfect. That's our congruent sign. So what am I going to put after that? Segment AB is congruent to
Segment EF.
segment EF. I like how he adds segment with it. Segment EF. And we have to have that line. So notice the difference. Lengths are what? Lengths are
equal.
equal. Segments are
Congruent.
perfect. Okay. We're going to try this example with algebra. First, what would I do? So I'm a visual learner, so what am I going to do first?
Make it short. I don't know.
Do I have a line drawn, a segment drawn?
Nope.
So I'm probably going to
Draw.
draw it. L, N, and my M is somewhere in between. If I were you, I'd follow along with this because you'll have problems like this. What does it tell me that LM equals?
3x plus 8.
3x plus 8. 3x plus 8.
Black.
Is it hard to see?
Yeah, it's not coming in. Or, I don't know where she got that black.
That's still hard to
That's
see.
better, yeah.
Okay. 3x plus 8, and what does it tell me that Mn is?
Mn is 2x minus 5.
2x minus 5. Ln, what is this distance?
23.
23. What postulate tells us that we can add these together?
The segment addition one?
Postulate.
So, that's what I'm going to do. And I have this chart drawn because I want you guys to see the reasons what we're doing and why we're doing it. So, I'm going to add these two together. Because we can do LM plus MN equals LN because of the, what'd you tell me why?
This
The
segment.
addition postulate, right? So now, do we know LM? What was LM?
3x plus
3x plus 8. What was MN?
2x minus 5.
2x minus 5. And do we know ln? Do we know what that equals?
23.
23. Now, what did we do then? We did what with these two? What's that S word that we used?
Subtract.
We plugged ln.
Subtract.
ln. I heard it.
Substitution.
Substitution. So
Alright,
that's
that's
why.
not what I was gonna say, so.
I was gonna say like.
So that's why we can do that. Now,
You had like terms.
perfect. Like terms. What are my like terms in here?
3x and 2x.
2x.
3x and 2x becomes
5x.
5x. What else?
8
plus
negative
an
5.
8 minus 5 gives us a,
3.
and we have our 23. So I did combine like terms.
Should be writing this down.
Then what am I going to do?
Subtract.
First step,
3.
subtract 3. We get 5x equals
20
20.
divided by 5.
So I subtracted. Then divide by 5.
And x equals 4.
X equals 4. So we found x. All we have to do to find the length is do what? We have x. Plug it in.
Yeah.
So if I get 3 times 4 plus 8, what do we get?
20.
12 plus 8. If I plug in here, what do I get?
15. Or, no.
3.
3.
8 minus 5.
3.
So when I write this, my distance of LM equals what? What did we say it was? My distance of LM?
23.
Equals
LM, just
20.
LM.
20.
And my distance of MN equals?
3.
Add them together, do we get 23?
Yeah.
Perfect. Good. So, we did not have time for the Kahoot, so we'll do that at the beginning of class tomorrow. But I want you guys to write this assignment down.